cosine rule. Alright, so in one of our previous videos we've considered that of sine rule, and we said that a brief summary that for a sine rule, and in fact for each of the rules, we make use of the two of them in solving triangles. And so if we have something like triangle ABC, and then we want to solve for maybe some of the missing some of the parts, maybe some angles missing and all of that, or maybe some sides missing. So you make use of the sine rule. Now please take note of this, that sine rule is used when a particular triangle has some properties. And what is that? About two properties. One is if we have two sides and an included angle, or let's just say two sides and an angle opposite to one of the sides. Opposite to one of the sides. Okay, so if I have two sides given, for example, something like this, let's assume that this is given as 5 and here is given as 3, and then an angle that is facing one of the sides, let's say 80 degrees, is given. So with this kind of diagram or example, you can make use of your sine rule. Okay, and then another kind of situation where sine rule works is if we are given two angles and a side facing one of the, or any side, two angles and any side at all. So if we are given two angles and any side, then sine rule can work. What does that mean? If I have something like this, let's assume they gave me here as 50, here as 60, and then any of the sides is given. Let's take it that we are given here as 2 cm. So with this, we should be able to also apply our sine rule. And the reason is because if two angles are given, then the third one is also given, because we can easily use the sum of angles in a triangle to get the remaining one. So any of the sides can actually work there. And why is because you recall that the formula is A all over sine A equal to B all over sine B. For example, let me use these two. So let's take it that here is my ABC. Alright, so let's even assume that I was not given here. Let's take it that it was the C that was given as 2 cm. And you can see that angle C is not given. And for me to make use of this side C, I will need the angle C. So all I need to do is to use some of the angles in a triangle to get this. And to do that, of course, since the sum of the angles in a triangle is 180, then if you sum this, which is 110, subtract from 180, you will get that here will be 70 degrees. So with that, I can easily make use of A over sine A and C over sine C to be able to solve for the whole triangle. And I can use B over sine B equal to C over sine C and the rest. Okay, so these are the two major conditions for solving a particular triangle using the sine rule. Okay. Alright, so but in this lesson we are going to be looking at the cosine rule. Alright, so the cosine rule, we also have a triangle, let's say of this form, and here we have, assume that this is our A, B, and this is angle C, and in like manner here will be side A, side B, and side C. Okay, so let's, if we take this as our triangle, what is the statement of the cosine rule? In a subsequent video, I'm going to be showing us the proof of the statement. So this one also connects the sides and the angles of the triangle. And what does it say? It says that if I pick a particular side, my A, and square it, that it is equal to the square of B and that of C minus 2 times the two of them, which is BC, then times the cos of the angle of this one, which is A. Okay, so by implication, what it means is that we can actually write this for all the sides. So I can write for b squared, and that is equal to a squared plus c squared minus 2ac, and then cos the angle of this, which is what? B. And I can as well write for the third one, which is c squared is equal to, which is angle C. So this gives us the three statements of our cosine rule. So the cosine rule is summarized in these three formulas. Alright, and the question now is, what form of triangles are we going to make use of the cosine rule? I've stated the two types of triangle you will have, and the sine rule will work. What about the cosine rule? So the first is that if you're given a triangle with the three sides, where the three sides are given, so if the three sides are given, then I can use the cosine rule to solve for the three angles. Remember, all we are doing here is how to solve for a triangle completely, to get any missing side or angle. So if all the three sides are given and the three angles are missing and you're asked to find them, then you can make use of the cosine rule. Alright, so that is one. And then two, if two sides are given and an included angle. Okay, so the question now is, what is the meaning of an included angle? So look at it here. If you are given a triangle of this form and you are given two sides, let's say here is 5 and let's take here to be 4. An included angle is at the angle between the two sides. So you can see the examples we have here. Look at this. This example here, is showing us this condition. All two sides are given and there is an included angle. An angle between the two given sides. So if you watch here, the three sides are given and you're asked to find one. The same is applicable here. The three sides are given and the same is applicable here. So the example 1 is what satisfies the condition 2. So if any of these two conditions is seen in an example, then the cosine rule should be used. So what is that? If you're given three sides and you're asked to find the three angles, cosine rule. If you're given any two sides and an included angle, then the cosine rule should be used. Alright, so quickly, let's look at the examples that we have below. Alright, so quickly let's look at some of the examples we have here. Solution. Okay, so for number 1, we are asked to calculate the marked angles and sides in the diagrams below. So here a side is marked, here an angle is marked, an angle is marked, and an angle is marked. Alright, so like usual in our channel, I'm going to do some and you will do the rest as exercise. Okay, so quickly let's begin with the example 1. So here, if we choose to give names to this triangle, let's say we call here, since here is called X, then let's call here capital X, let's call here Y, and let's call here Z. So that means we can now use this, of course here will now be small y, and this one will be small z. So now let's use these letters to write our formula. So what is it going to be? Remember what I said, you pick the side. So since x is what we are looking for, we start with x. So x squared will be equal to the square of the other two, which is y squared plus z squared minus 2 times the two of them. You don't need to cram any of these formulas, just understand the pattern and it's easy to recall each time. And so the cos of the angle of this one, which is capital X. Okay, so quickly let's now substitute. What is our y? Our y is 16, so we have 16 squared plus we have 11 squared, that's our z, minus 2. Alright, so what is that going to give us? The square of 16 is 256. The square of 11 is 121. And if we multiply this, 2 times 16 is 32, times 11 is, okay, so we have 352. and so multiply now by the cos of 32. Alright, so approximately to 3 decimal places. Now please take note that one of the common mistakes we make is to add up this and subtract before multiplying. That is not going to give you the correct answer. So what do? You first of all add, and so bring it down. So this is going to give us 377. Then bring down minus. Then multiply this first before you now subtract. And so if we multiply this, what are we going to get? Alright, and when you now subtract, remember that this is our x squared. That's going to give us what? Alright, so now and finally, our x is going to be the square root, of course, the positive square root of 78.6, and which is equal to, so we have 8.87, and the unit is centimeter. Alright, so that is equal to that. Okay, so, and if we choose, since all of those are in whole numbers, we can choose to put this one in whole number also, and that will be approximately 9 centimeters. So that is the solution for example 1. Okay, so and for example 2, you are asked to find an angle. Okay, so what do you do here? You can begin by giving names to this. So let's say this is ABC. So remember that from here, if I make use of my side C to write the formula, that's going to be C squared is equal to A squared. Now, but because the angle theta I'm looking for is equal to C, that's why I use this. So all you now need to do is to make cos C the subject and then look for the value of C. And if I make cos C the subject here, I can move everything here to this side and move C squared to that side. This is negative, so it becomes positive 2AB cos C to be equal to A squared plus B squared. This one coming over becomes minus C squared. And so my cos C alone, if I divide both sides by 2A, will be A squared plus B squared minus C squared all over 2AB. Alright, so with that, I can now substitute. Remember, I have the 3 sides. Can you see now how that works? So the 3 sides, I have my A, which is 9, and I have my B, which is 8. Okay, so I can substitute those 3 now to be able to get my final answer. Alright, let's quickly do it here. Alright, so if we substitute, so that means that our cos C is now going to be equal to, my A is 9, so I'll have 9 squared plus my B is 8, which is 8 squared minus C, which is 12, so I'll have 12 squared here, all over 2 times A, 9, times B, which is 8. Alright, so this is going to give us what now? 9 squared is 81. Alright, and if we subtract now, so 81 plus 64, so that will give us 145 minus 144 all over 144. Now see what that is going to be. That will be 1 all over 144 as our cos C. So, and if we put this in decimal, what is that going to be? Okay, so this is 0.0694, and that now means that my C alone is now going to be the cos inverse, because cosine will come over cos inverse of 0.0694. Okay, and remember that our C, like we said here, is the same thing as our theta. So therefore, our theta is equal to, so that's approximately 86 degrees. And that is the value of our angle theta. Alright, so like I said, I'm going to take just the example 1 and 2. And I will allow you to look at example 3 and 4. So here, find the value of theta here. You can give it a label of your choice, P, Q, R, or whatever, and the same thing applicable here. So in the comment section, you are going to tell me the value of theta and the value of x.